Right. Hello, everyone. Uh, in this session today, we'll be covering the another segment of OOPS, that is object-oriented programming, which essentially covers the concepts of classes and object. In the preceding session, we already understood the whole context of what a class is, what an object is. So basically, a class is a blueprint or a template from which we derive many objects, or we create many instances, if you were to talk in the technical term. In today's session, we are going to learn further into the further concepts into the object oriented programming. We are going to learn what inheritance is and what encapsulation is, the whole concept. Now, because of this inheritance and encapsulation, the OOPS or the object oriented programming is such a predominant and prevalent in the industry. In fact, initially when C was widely adopted in the industry in 1970s and 80s, the whole and the mere reason for the growth of C++ and its adoption was only because uh, the C++ supported the object-oriented programming style. Okay. Now, in the object-oriented programming, the good thing is, if we were to relate, see, just like we used to create functions, once we create a block of code and we name it, we create a function out of it, that we can always call it any number of times. We can always use that function any number of times in our code to get a job done, to do any task, isn't it? And if you pass on that function around, the other people can also use that block of code, right? If you pass around too many functions in a module, as a library, as a separate external file, everyone can use that, right? With that analogy and with that as a context, even the class and objects, if you dump your logic in classes and object, not only you make it modular, that means you contain you make a template or blueprint of something and you can make objects out of it, but you can also pass around these classes also as a separate module, right? But what apart from this does the concept of OOPS and the classes object have for us? And that is the concept of inheritance and encapsulation. What are these technical terms? Inheritance and encapsulation is, we are shortly going to learn today in our sessions. But before that, let's look at the example we had created in the last session and try to understand that uh, for a little bit into it. So many of you might be having the query that why did we write this, isn't it? I mean, of course I defined the whole instruction within the class person, and here I am instantiating. That means here I am creating an object. I'm here, this is like just like you invoke a function, just like you trigger a function call. This is like you're calling the class, you can say, in layman's term. This is creating an object for you. So when you call this person, you're basically triggering this class and you're providing these details, Michael and 30, which actually are received by this method or this function. Okay. And using these, whichever person or whichever student is being created, that student's name will be, specific name will be Michael and the age will be 30. However, every student that you create using this class person, the genome is always going to be same mammal. All right. Now, if you think why did we write this particular block of code, why did we write this? Then we wrote in it because, see, this is called as instantiation. Okay, you know that instance, the English word instance means example, right? So student 1 is an example of person, student 2 is an example of person. But what is the difference between student 1 and student 2? Both are mammal, of course, but the name will be different, right? The age will be different, right? So when you are calling this particular class, the individual data that you're providing, this particular function or this particular method is basically initializing, as the name goes here in it, it is initializing that corresponding student which is under construction. So right now it is student 1 which is under construction, so it will initialize only its name to Michael and its age to 30. Okay, and your student is created, but and the next time when student 2 is under construction, okay, you are providing Alizan as a name and 32 as a age. So what happens is this time you again jump to this particular class to create student 2, to create another instance of this class. And in this time, of course, you will set the genome as mammal as usual. But now, when the student 2 were to initialize with some specific data, this time it will be Aliza as a name, okay, and age will be 32. And that's why you can see that when I'm printing genome, name, and age for both the student, the genome turned out to be same, mammal and mammal, but name turned out to be different. Why? It is because of this particular init method. Okay, this is responsible to initialize the corresponding object which is under creation to the specific values. All right. Now let's learn the whole concept of inheritance, which is really good concept. Okay, suppose I want to create another class. Now let me delete this piece of code. Now you can see that it is a person. Okay, it's a person, or I can say human. Okay, let me rename it as a human. So human G name is mammal, and I can say maybe um, okay, name and age. Fine, that's perfectly fine. Let me create another class which is called as student. Okay, this time I'm creating a class who's student. Okay, now while I'm creating another class student, see, when you're creating a class, you can put parentheses here, or you, if you don't put, that's fine. But if you think that you have to inherit something, in biological term, what is inheritance? Whatever genes that your ancestors had, or what your parents had, your skin tone or the hair type or your height, there are genes that you inherit from your parents or your uh, ancestors, right? To you. The same you can imagine here. If I am creating a class here which has attributes like name, age, and genome, if I am writing this human here in the bracket, what's happening is this new class which I'm creating, student, that is inheriting the human class. So there is a already architecture present within human. This is being inherited by class student. All right. uh, so what I mean by this is, suppose now I create another let me see here, in it define, okay, double underscore. Why do we put this double underscore? I'll tell you later, but mind you that this has to be double underscore and you write in it, okay, all in small followed by double underscore and you write self. Okay, the whole reason why do we write self is because I know you must be confused. Why are we writing self like this? What is this whole syntax? This is just convention. Self dot name, it means, like I said, this particular method is setting the specific values to that particular object which is under creation, right? So self tells Python that I I am referring to that object which is under creation. So it is just a reference. Okay. So every time a new object is being created, this self is actually referring to that. That is why we write self here. Okay. So here, let me say uh, Z here. Okay. So this is just a temporary variable. Now here I'm going to write self dot major as in which field he has majored in or done his graduation. I will write Z here. Okay. Okay, let me not write human at the moment. I'll shortly tell you um, when and how we are going to use human. So let me write here person one. Okay, so the person one is a student. Okay, person one is a student, and let me also write person two is a student. Within this student's brackets, I'm going to provide mathematics. Okay, so he has done his honors in mathematics. All right, and here I'm going to write here mm, political science. Political science. All right. Now, if I try to print P1 dot major in the similar context, if I put P2 dot major, you will see that I'm getting the responses mathematics and political science, right? So basically, these two, person one and person two, they are created using the class student, and the only attribute that they have is major, right? However, if I want to inherit these properties or uh, these attributes, I can also write this particular human class within this parenthesis. Okay, I can write here something like this. So what's happening right now is this is called as base class, okay, or you can say super class, and this is called as derived class, because this being super class or base class, from this is deriving. What happens is once you derive this, you are basically inheriting all the attribute and method that this class has defined. You're defining into this particular class. Now see, when you're creating student, you are initializing every student with major, right? And since you have also inherited the base class, that base class also expects initialization, isn't it? Right? So what I'm going to do is, let me also provide extra data like name. I can say here Aditya, okay, and age could be 25. Here I'm going to write Neha, and the age could be 30. All right. Now these two extra values which I'm sending across while I'm creating my student, let me receive them here Z, and I'll write U comma V. Okay. Now mind you, you need to also trigger the initialization of your base class. Okay, so one way to do this is you can use this super function. So you have to write like this: super dot underscore underscore init underscore underscore, and then here you'll write u comma v. Okay, I know this could be a little bit confusing, but just remember, now what's happening here is very simple. Here I am constructing a person as an object. Okay, one student is being created here, one student is being created here. You're providing three data: mathematics Aditya and 25, political science Neha and 30. Why so many data? Because one data shall be utilized here in the student itself, and two data shall be further passed on to the base class or the super class. So you know that the moment you call this particular class, the initialization is going to happen, right? Whichever student is under creation, object is under creation, for that initialization will happen. Within this initialization, you are also first initializing the base class. So I can write like this: super, okay, and then init uv. So what happens is I am now from here, I am triggering the initialization of this. Now what happens? Now what is the whole use of inheriting the human? The whole use is that it is not just the major that I can access, but now I can also access the name. I can also access the age. You can see here age. So if I run this, you will see that Aditya and 25. So you see, although P1 and P2, they are the objects of the class student, but yet it is not just the major that I could access, but I could also access name and age. How? Because this class now not just the student, just like student, I can have more here. Say I can create more class like class uh, players. Okay, I can again here write human. Yeah, because end of the day, who are the players? They are also human, right? If I have to create another class, why should I rewrite the whole code? Why should I create the attribute name and age again? That's a waste of memory and time, correct? So what I'm going to do is I'm going to uh, self n comma m comma v. Okay, c. Okay, these are the temporary variables not used. Okay, here I can write super dot init m comma c self dot sports is equals to n, and that's all. So what's happening here? You see, I know it could be confusing that I have written so many classes, but it is just I want to keep my point that if I have to create a student or if I have to create players, even a student is going to have a name, attributes like name and age. Even the players is going to have the attributes like name and age. Why should I write this piece of code repeatedly? Yeah, to save such to keep it more efficient, to save the memory, what we do is we create a base class. Okay, and that base class we can directly inherit. And in the base class, when we inherit the base class, the new class that you're creating, the derived class, it is going to inherit the properties like this. So it becomes easy for me. So let me remove this player. This was just for the example. Let's not clutter our screen and confuse you guys. So here you can see that although the class student has created an attribute major, but because I inherited human, these attributes which were defined in the base class, they also got associated with the student object that got created. Right now, one more thing is, it is not just the attributes that could be defined in a class, but also even the methods can be defined in the class. Now, what is methods? See, certain data like person or car or aeroplane, these kind of concepts or the data, they are not straightforward data. They are not data like 5 comma 10 or 15. No, they can have many attributes. Like a person can have height, weight, color tone, you know, age, citizenship, but he can also have a behavior like he can be sing or um, play or introduce, the ability to introduce yourself. So we can also define the behavior here. For example, if I write define introduce, okay, introduce. Now this is called as method, or of course it is a function which you're defining. But what is a function? It's a block of code that is doing certain job, right? So here what I'm going to do, say self. Why do we write self? Because it corresponds to this behavior is corresponding to that particular object which is under creation. Okay, so here if I write print hello, I am, after the string I will print self dot name. Okay, so this class is going to extract its own corresponding name. Okay, so if it is person 1, it is going to extract the name of person 1. If it is person 2, that's how. Okay, now let me write, and my age is, I'm going to write here self dot age. Okay, and I'm going to write here is greetings to all. Okay, now let me do one thing. Let me call this particular method. So just like I was accessing the attribute of the objects that I created, I can also call the method. Okay, so I can write here introduce person1 dot introduce. So what's going to happen? Let's see. Sorry, that's the wrong thing that I printed here. All right. Mm-mm-mm. Okay, like that whenever you call a function, you should always append it with parentheses. So you can see here that you see it says, okay, I need not put print here because of course it is returning none. I can just say p1 dot introduce. So what's happening is I am jumping into that function for the student. So, and I print the introduction here. So it says, hello, I am Aditya. How did Aditya come? Because I am referring to my own name. Yeah, whichever object called. So self, this is what the role that self plays. Whichever object is calling, that self is referring to that. So here it says p1 dot name. Okay. So here it says, hello, I am Aditya and my age is 25. Greetings to all. Now, if I say uh, p2, if I write here p2 dot introduce, you shall see that it says, hello, I am Neha and my age is 30, right? So this is what happens. Okay. Basically, you can have such attributes and methods both in derived class and base class. Okay. Uh, the base class is created because we know that this piece of architecture or this piece of blueprint or template, you can say, is going to be inherited or going to be used in many classes. Like I created a player, like how we created student. Maybe there are many things which are going to be common in those. So rather than rewriting our code, rather than reinventing the wheel, since we know that it is already created a human, we will prefer to inherit the human. Yeah. So this is the whole concept of inheritance um, in classes and object, or in the approach of object oriented programming. Well, uh, it is wise to note that, of course, the coding in Python could be done with or without the concepts of oops or the object oriented programming. But the industry, whether it's IT, healthcare, aerospace, automotive, whoever using the programming language which supports object oriented style, they use classes and object widely. Yeah. And inheritance helps them save the efforts. So if they have created say a piece of code in one particular class, going forward every new class that they create, they are going to keep on importing that particular base class. So that helps them to avoid rewriting the code and create the clutter in the code, right, and keep it more efficient. So that's the whole point. Now, that was all about inheritance. So inheritance is nothing but it is like an importing all the features from the base class, whether it's an attribute or whether it's a method is nothing like the this you have created, right? So I can create the same thing here also. Define, it's not introduce, I would say, speak. Okay. Or maybe I can say sing. Okay. So okay, let's take a basic one. Walk. Every human can walk, right? And I'm going to write self here. Okay. And I'm going to write print self dot name comma walking. Okay. So of course, I am not writing any other code just to keep my point that this behavior which is defined in the base class, that is also can be inherited in the derived class, so the new class that we're creating. Just to show that, let me write here walk. All right, let me write here p1 dot walk. Okay, and you shall see that Aditya walking. Let me now make it p2 dot introduce and p2 dot walk. And you see here, it's hello, I'm Neha and my age is 30. Greetings to all. Neha walking, right? So that's the concept of inheritance. Now let's focus on what uh, encapsulation is. Well, let me write here. This was the whole concept of inheritance. Okay, this was inheritance, what I just explained. Now let's learn what encapsulation is. All right, let me take the same thing. Yep, let me take the same thing here. Same example so that it is easy for us to learn. right? The encapsulation is sometimes the class and the object that we have created, they might contain sensitive data, okay, which we may not want others to reveal. So for example, if you're creating a banking application wherein you have written here, say, person, and you can also have an attribute like account balance, okay, the balance that the person has. So what happens is, you definitely don't want anyone, this code, if you're circulating around, you don't want anyone from the outside to suddenly access the internal data. So many objects you're going to create using this classes, right? Say person one, person two. In fact, say if you're considering a banking software, so many accounts are every day created. That means you can imagine that as every new account is being created, all such data you might be storing here in the class, isn't it? This is something sensitive. You don't want outside world to access it, right? So at the moment, if I say, if I write here, say account balance is say 500, and here I write the account balance is 10,000. Here, if I say, here if I try to access, let me print this. And the similar way, if I try to print it here, say P1 dot balance, both will be printed. You see, both the details are being printed, isn't it? And in the same way, if I try to say P1 dot introduce, and the same way P2 dot introduce, so I'm triggering a method here, isn't it? You can see that account. Okay, something happened. There's no age. All right, so age was deleted here. Let me write here account balance, and my net worth. Net worth is okay. So you see here, uh, this attribute is revealing a detail which is sensitive. This method or this function is also revealing certain thing which is sensitive, isn't it? So if you don't want, if you want something to be, you want something to contain, you don't want to reveal it out, you want to protect it. That's there is a mechanism to put in a security there, okay, to hide it. That is called as encapsulation. So it is called as access modifier. You can modify the level of access these attribute and methods can get. Right, so there you can provide the access modifier there. The first level is called as public, okay, in access modifier public. The second one is private. The third one is protected, okay. When I say public, at the moment everything is public, and that is why it is being revealed out or being able to access. So be it account balance or introduce, whether it's an attribute or whether it's a method, you're able to access out. But when it comes to private, if you put double underscore in front of the variable name like this, let me put it in front of account balance like this, and similarly let me put, I'll have to change here also. Yep. And if I try to access now, you shall see that it will throw an error that has no attribute account balance, right? Why so? Now that's because preceding the attribute name by double underscore, it tells Python that the nature of this particular attribute is private, and the private things are not inherited. So they are neither they will be inherited nor they will be accessible to the outside world. So even if I call this particular, see, let me remove this, and even if I try to trigger this method call, and if I run this, you will see that it says self dot account balance. It has no attribute. So student, the base class has no attribute. Now, not that it doesn't have attribute. Definitely it has that attribute, because if I call walk, okay, then you can see that. Let me print here in the walk. Okay, not walk. Let me change it to, say, tell balance. Okay, and let me write here tell balance. So if I run this, and if I'll have to change here, ECCPAL balance. Okay, so if I run this, you will see that, you see this particular attribute, it is only visible within base class. So when I called the attribute or the method of base class, I am getting the balance. But if I try to access the balance in the derived class, or if I try to access the balance directly uh, outside, I will not get it. So if I try to access the balance, so if I change the method call to direct attribute like account balance, you shall see that it will be inaccessible. Correct? So the whole purpose, you see, it's giving an error, attribute error, that there is nothing called as account balance. It is not that there is nothing, but you will just not be able to balance. Okay. It is not that there is the account balance is not there. It is just that from the outside world you will not be able to access, because I have put here the access modifier. Now this protects the attribute to the from getting exposed to the outside world, and not just the attribute. You can also associate the private access modifier to the method also. So if I write this particular one like this, if we double underscore, then this method will also get hidden, and you cannot call this method outside this class. Okay, so if I try to access this one, since human class is inherited by student, obviously the everything should have gotten inherited, right? Every attribute should have gotten inherited, every method should have gotten inherited. But here if you see, I have put the access modifier, which tells that this thing is private. So nor this method, the capability to call this method will be accessible to the derived class, nor, unlike last time, you can call it from the outside world. So if I write here tell balance, it will give up an error. You see, it says that there is no attribute. But the moment I remove these double underscore, it becomes okay. I have to remove from here also. Yeah, the moment I remove, it says 500, right? So it becomes immediately accessible. So this is called as private. Okay, private contains the attribute and method to that class only. And now the next thing is protected. Okay, so in when something is protected, I will just put one underscore. Okay, whether the attribute or whether the method, I can just put single underscore instead of double underscore. Now it is not that just because it is protected it will not be accessible. Technically, when you're inheriting this class, even everything will get inherited. Even if it is protected, it will get inherited. Okay, so if I try to print it here, you shall see that if I write here introduce, it will get printed, right? So it is being accessible, and even to the outside world. If I write here underscore introduce, you will see that okay, it should be single. Yeah, now it's fine. uh, uh, Introduce, oh sorry, this is tell balance. Tell balance. So this method this method, which is protected, single underscore is protected if I'm accessing it outside. Okay, you can see that the method is accessible. Then why do we have a single underscore under the category of protected? Well, technically, protected attribute or protected method, they don't there is no, it is not, the protection is not enforced, but it is just a recommendation that please do not use it outside, please do not use it outside, please do not use it in the derived class, because the original developer of this base class, he can change this anytime, he can change the name, he can change the content anytime, and your program could be at risk. So if it is public, you can definitely use it outside, and even in the derived classes you can use the attribute, you can use the methods. But if it is protected, I mean if it is private, then private thing obviously they are technically cannot be accessed, because Python will not let you access whether it's attribute or whether it's method. And when it is protected, you can access it, but it is recommended that please do not try to access it. Okay, so this is all about encapsulation. So this security mechanism or protection mechanism which is provided here will let you protect your code or protect the sensitive data or functionalities which you implement in your classes and object in your code. Okay, so that is why the oops concept and the classes and object are so famous and are widely used in the industry concepts, right? And inheritance, like I said, is also very useful thing. Whatever you define here gets inherited uh, to the derived class. So that object which you're creating, it not only gets the properties of what you have written in the derived, but also of the base class. Yep. So that concludes the whole concepts of classes and objects and the uh, object oriented programming style. And like I said earlier, and I would like to repeat that whether you use the concepts of object oriented programming or not, you can still code, but these are very efficient way of programming. All right. And to get a better hands on or get a better understanding of these concepts, the assignment and the notes which are provided along with these recordings, please go through it and practice. Right. Thank you.